Hi again there. Today we are going to do something different. So I've never done such a thing, but I saw best we can try it. Here's a question paper. So done by the surveying 2 diploma in building, diploma in civil, diploma in architecture that was done on the July series 2023. Some of my learners said this paper was a little bit challenging, but I went ahead and did each and every single question. I don't see anything challenging. So let's do the revision of the whole question paper. Yeah. So let's go question by question, and I will see how I can explain by simple terms the best that we can do. So this is a survey revision of the July series 2023 paper. Let's go ahead. So the question paper, you can download it on the link below on the description. So just check there and you download the whole question paper. Question number 5. With the aid of sketches, describe the following types of curves. So there we have 4 curves. We have the invert curve, overt curve, compound curve, and the reverse curve. A total of 4 marks. Those two, the two curves, they were a bit challenging, but you can attempt the question because I'm sure all of you you just have a concept about the compound and the reverse curve. So that I think can be 2 marks, and the others you can skip. But I've gone ahead and done a little bit research, but also encourage if someone has an extra knowledge about the invert and the overt curve, you can write there down on the comments. I'll be happy. So the reverse curve, you can see there, the reverse curve consists of 2 arcs bending in the opposite direction. Their center lines lie opposite to each other. They already can either be equal or different, and they have one common tangent. There is the diagram. I went ahead and saw the reverse curve in other text. They have a different name. Someone can use it someone can twist the question, so you can look into that. So that word is a little bit challenging, but something like augury curve, but the spelling there is right. And then we go ahead to the compound curve. When a curve consists of 2 or more arcs with different radii, it is called a compound curve. Such a curve lies on the same side of a common tangent, and the centers of the different arcs lies on the same side. So in compound curve, the curve lie on the same sides, but the reverse, it's like an opposite, so they lie on different sides, so opposite direction. I went ahead and searched something that can be easily relatable to what we had been asked there. But again, anyone with a clue, you can write something down on the comments. So I went on to the vertical curves. So we had a sag curve, which was my invert curve. Then the summit curve, that was my overt curve or the crest. Those were just some of my researches. Any of you, you can say a clue or something about that. So this invert overt curve they're a little bit challenging, so the examiner can tell us more, but that was my little bit researches. So go ahead and do more researches on that. So question 5b, that was the interesting part of the question, a little bit challenging, or let's just say a little bit having an error, but we calculate it. So question 5b, in a curve ranging exercise, two straights are joined by a curve of radius 200 meters with a deflection angle of 70 degrees. If the subchords of 20 meters are used in setting out, and then determine the first question, tangent angle. We have the tangent length, curve length, length of the long chord, deflection angle for the 20 meter chord. Then the last question, the deflection angle for the last subchord. A total of 16 marks. So by the simple knowledge that you have, our first question, the tangent angle, it's obviously 90 degrees. I think that was what you are being tested to see if you have any of the properties of a triangle together with a circle. So the tangent length is 90 degrees, and then the tangent, so that is the tangent angle. The tangent length, our formula is r tan theta over 2. Our r, that is the radius, on the question there it is 200 meters. Then tan, our deflection angle is 70 degrees, so tan 70 over 2. If you are using the normal calculator, remember to first divide the 70 before the calculation, because it will give you a different thing. But if you are using the calculator that I'm using there, you can just key those values directly into the calculator and they will give you the answer. By doing so, our answer becomes 140 degrees 04 meters. So let's go to the next question. So that was 140.04 meters. We calculate the curve length. We have a variety of formulas, but that was my simple formula that I always use. That is pi r, the deflection angle over 180 degrees. So pi times 200 times 70 degrees over 180 degrees. Using the calculator, giving us 244.35 meters. We go ahead, the length of the long chord is equals to 2r sine theta over 2. So that is 2 times 200 sine 70 over 2, giving us 229.43. Then the deflection angle for 20 meter chord. So we were told the subchords, they are 20 meters, so that is a direct thing. By the use of a formula, that formula obtained and calculation of the curve by the deflection angle method, we have that simple formula there, that is 18.9 times the 20 meter chord over r, that is the radius, which is 200 meters. That formula is in minutes. So remember, if you do that calculation, your final answer, you have to divide it to with 60 minutes in order for your answer to be more simplified. So that formula is in radians, and we want to convert it into degrees, minutes and seconds. After having divided it by, your answer becomes 2 degrees 51 minutes and 53 seconds. Yeah, so this last question, we were asked to calculate the deflection angle for the last subcode. In all my previous calculation of setting out curves, we use our curve length, but in relationship to the first tangent, that is T1. But here in our question, we cannot calculate T1. Either way, we don't have the chain edge of intersection or any formula that can help us there. So I went ahead and did what you're seeing. Whether it is right or wrong, I'm not sure what the NEC examiners did on that question, but that was the simplest solution that I did. I'm sure even some of my students they did that. They told me that after the examination. So I've gone ahead and do the same. So from the curve length, I'm going to divide it by 20 meter chords to get the number of full chords that were present on the curve. Having divided there, you can see our full chords are 12. So we have 12 full chords, and that means our total distance covered by the 12 full chords was 240 meters. Go ahead and minus my curve length by, so my curve length, that is 244.35 minus 240, giving me 4.35 meters. That was the distance that remained in order for my curve to be complete, and that is the small code that I'm going to use for the last subcode there. The formula used earlier, yeah, that formula for the deflection angle method, that is 1718.9 multiplied by the last subcode, which we have gotten there as 4.35, divided by r, which is 200 meters. Then that formula is in minutes, so you go ahead after calculation, you divide it by 60, and our answer becomes 0 degrees 37 minutes and 23 seconds. So that is what I did. Yeah, let's go ahead. Question 6. Question 6a, the bearing OA and the included angle OA as shown in the table below. So that table, we have the bearing of OA and we have the angle of AOB given there for 4 different readings, and then we go ahead, we are being told to determine the bearing OB in each case. A total of 8 marks. I'm not sure if my student did this question. I don't know why, but this is among the most simplified question available. So question 6 was the easiest because it was correct. Everything was right. So let's go to the solution. Let's first start with the first reading. The bearing of OA given to us. I've demonstrated the diagram. So OA, we have a bearing of 318 degrees and 16 minutes. Then the angle in between AOB shown in the diagram there, that angle is 331.14 degrees. So that angle is plenty. So I went ahead, so we rotated, so something like a rotation, yeah, like an external angle. Solution as simple as, so the first thing I did was to find the remaining distance covered by my bearing of OA to where the north was. So 360 minus 318 degrees and 16 minutes, getting a total of 41 degrees and 44 minutes. So that is the distance that was covered from our line to where our true north is. Then I went ahead. So in order for me to determine the bearing of OB, that means that external angle subtracted with the value that I've gotten, because all bearings have to start on the magnetic north. So that is the true north. So I went ahead and subtracted the angle there. So that is 331 degrees 14 minutes minus 44 degrees 41, that is 41 degrees 44 seconds, getting my answer as 289 degrees 30 seconds. So that was simple like that. Or you can go ahead and use this other way that I got. So you add the bearing and the angle. If your answer is more, you will subtract 360. So addition of those two angles, you get there 649 degrees 30 seconds. After getting the total, you subtract 360 degrees and your answer becomes the same. So that is a different way a friend of mine showed me, so mostly used in land survey. Yeah, so that sounds easy. So my answer remains the same. We go ahead to the second observed reading. So bearing OA, there we have 18 degrees and 26 minutes. Then the angle in between, so AOB, that is 194.25. You can observe I've illustrated there on the diagram. So you remembering, so all my bearing, so the bearing of OB has to start on the magnetic north. So that becomes simple. I'll just 194 degrees 25 minutes plus 18 degrees 26 minutes, getting my total answer as 212 degrees 51 minutes. So that is just simple, just like that. Now we go ahead to our third reading. So bearing OA, that is 168 degrees 11 minutes, and the angle between AOB, that is 212 degrees 14 minutes. I've gone ahead and illustrated that. So the bearing of OA, there we have 168.11. I'll use, so that is 360 minus our angle there. So I'm looking for the angle that remained in order for me to reach to the, so it's just like a rotation. So the angle the remaining there is 191 degrees 49 minutes. The internal angle of that reading AOB, that angle was 212 degrees 14 minutes. So in order for me to know the bearing of OB, that will be so that will be, I will subtract, and after subtracting, so I'll subtract my answer there with my internal angle, and I will get 20 degrees and 25 minutes, or the other simplified formula, you add the bearing and the internal angle, and getting your total answer, you subtract it by 360 degrees, getting our final answer as the same. We can go ahead to the next solution. So we have been given there our bearing OA, that is 238.54, and the angle AOB, that is 16 degrees and 12 minutes. Given that, that becomes simplified. So OA, we have the bearing there, then the distance so the angle between A and B, the internal there, we have that. So remembering our bearing, we have to start on the magnetic north. Yeah, so let's go ahead to question 6b. Yeah, question 6b, we have been asked to get the bearings and the distances of AB. So the question given below are the coordinates of points A and B. We have been given the eastings and the northings there. So easting for A, northing for A, easting for B, and I've done that correction there. So the northing for B given there. So those are the datum coordinates of points A and B. We have been asked to calculate the bearings of AB and the distance apart. So that is the distance AB to a total of 8 marks. Let's go ahead. So they have displayed some of the formulas that you can use either to get what you are asked. Yeah, you can see so that is just for revision. So let's go ahead to the solution. So length AB, we have length AB, that is the square of the difference between the easting of B minus the easting of A squared plus the northing of B minus the northing of A squared. So remember to use your calculator, right? So by adding the squares of those two and finding the square root as seen there, our distance becomes 6,643.19 meter. And then the bearings, so that is tan, the bearing of AB. So ahead, we go ahead, that is the difference between the easting of B and A divided by the difference between the northing of B and A. And if your answer, so you can go ahead and you can use the calculator. So I'm using a scientific calculator. It does things more faster and more accurate. Remember, you're using the basic FX82. Remember to put your brackets in all your calculation to avoid errors. Having divided those two, your answer, you do the tan inverse in order for you to get the angle. And here in our case, our angle had a negative. So by applying the trigonometrical equations, so there we go ahead and add 360 in order for us to fall on the correct quadrant where our tan had a negative. So by adding 360, our angle becomes 274 degrees 58 minutes and 29 seconds. again, but I'm not sure if you are allowed to do this. So this is a 8 marks question, so that was the suitable solution you can do. But again, here we have more simplified calculations. I've displayed there some formulas used by calculators. So for those using the FX82 MS calculators, you can use the formula that I've given you there. So, but I'm not sure that could earn you 8 marks in an examination. So we go ahead. So it is important. So if the difference in the easting or the difference in the nothing is a negative, remember to type the negative before the number. Yeah, remember that. So on your calculator, you go ahead and you press the button there where we have the pole. You subtract, so you pull the difference in the nothing first, comma, then the difference in the easting, and remember here we are subtracting the easting of B minus the easting of A, and the same the nothing of B minus the nothing of A. You close the bracket, you press the is equal sign. So there it first gives you the distance. Yeah, then after doing that, you go ahead and you recall. So that is you press the button there, RCL, then you press the F there, the F on the calculator. After doing that, it gives you the bearing. It gives you the bearing, and remember, if the angle is greater, so there, if your answer has a negative, you can remember you add 360 degrees. After doing that, you press the button there where we convert it to degrees, minutes and seconds. You can try that in a more advanced calculator. So the solution is given directly. You go ahead, you pull the difference in the nothing and the difference in the easting, and by pressing the equal sign, it gives you both the distance and the angle. So in more advanced calculator, it is a little bit easier. So that was just a simple way I've shown you. You can use that, but on this question you had to do the longer method. Question 6C, convert the following reduced reading to whole circle readings. There that is south 20 degrees 30 minutes east, north 18 degrees 10 minutes west, north 80 degrees 50 minutes west, and south 27 degrees 20 minutes west. Total of 4 marks. So then the solution, we have that table. You can observe it and take notes. So those are just ways on which you can apply. So I've illustrated the quadrants. So we have 4 quadrants, and those 4 quadrants are represented by the 4 cardinal points found on the compass. So I've gone ahead and just answered the question directly. So our first solution was found on so that is southeast. That is found on the second quadrant. So in the second quadrant, and remember in all this calculation, so all my values, they have to touch the major cardinals. So it's either the north or the south. So my angle, you can see in the illustration, comes from the south. So that is from the south anti-clockwise, moving towards the east. So I'll go ahead and subtract. So 180 minus 20 degrees and 30 minutes, and my answer becomes 159 degrees 30 minutes. On our second question, that is the northwest, that is northwest. You can look at the illustration, that is on the fourth quadrant. That means my angle was moving on, so that was anti-clockwise from the north going downwards, so that was anti-clockwise. So you go ahead, that is 360 degrees minus 1810, getting our answer as 341 degrees and 50 minutes. Then on our third question, that is still on the fourth quadrant. So you again minus our 360 minus 80, 50, and you get your answer as 279 degrees 10 minutes. Then on our last part, so southwest, that is found on the third quadrant. That means the value that I have there came from the south on a clockwise direction, moving towards the west. So I'll just add 180 degrees to the 2720, and my answer becomes 207 and 20 minutes. So that was just simple, just like that. Question 7a. State 5 factors to be considered when selecting a traverse route. Total of 5 marks. The first point there, the traverse legs should contain more than 10 legs before closing. Number 2, the number of stations should be minimum. Number 3, the stations should be located on a firm ground, so in order to avoid the errors. So if it is on a loose ground, the station will be movable, so it will slightly move when a natural weather condition affects the, or even a person. On the fourth point, so the station should be so located that from the traverse line all the details of the area can be plotted. Then our final, the stations when closed should be placed in such a way that there will be no more displacement. So that was the theory question. Question 7b. The observed internal angles in a closed traverse of 6 sides are given on column 2 of the table below. So there we have the angle and the observed values. So we have the all the angles there. So A, B, C, D, E, F. We are told to adjust and give the values of the observation, a total of 12 marks. My learners translated this question. I don't know how they translated it, but I don't know, but they did it somehow wrong. So here the observed values, those are the internal angles. So this question was not said directly, so they thought those were the normal bearing, so the 4 bearing, but those are the internal angles of all those points. Let's go to the solution. So our first thing, we add all the internal angles. After adding all our internal angles, we see if our answer is either correct or there was an error. By adding all those internal angles, our total answer becomes 717 degrees 0 minutes and 2 seconds. but the sum of internal angles, there we have a formula, that is 2n minus 4 multiplied by 90 degrees. N is the number of sides. So by either drawing or observing, we had that was a 6-sided figure. So 2 times 6 minus 4 multiplied by 90 degrees. We are supposed to have all our internal angles as 720 degrees. So there we can see an error. We go ahead and subtract. So that is 720 degrees minus what we had added earlier, the observed values. So by subtracting the total of the observed values, there we see we have that is a negative error. So of 2 degrees 59 minutes and 58 seconds. We need to correct the observed values. So that was what we were told. So adjust and give the values of the observation. They were asking you to correct those values. That is the error for the total figure. If we want to correct that, we'll divide by the number of angles obtained there. So that's A, B, C, D, E, F. Those are 6 angles. Yeah, those are 6 angles. So by dividing that, the error, so we are supposed to correct it with a positive error of 0 degrees and 30 seconds. So I've rounded it off there, but when you divide it, my answer can either be that or 0 degrees 29 minutes and 59 seconds. So you add the misclosure error to all the angles. I have gone ahead and put it in a more beautiful solution in a tabular form. So there we have our first column having the angles, the second column having the observed values, then the third column having the adjusted, we have the adjusted, then we have the correct adjusted value. First of all, I tried correcting that by what I had there, but my answer, it either was a less or a more. So I saw a best solution. You can play with the adjustment as long as it is within what you had there. So there, before rounding off, so it's either I had 0.29 0 degrees and 29 minutes and 59 seconds, or if I round the answer off, I have 0 degrees and 30 minutes. I'm going to play with those adjustment. So in the observed column, you can see there, I either used the one that was rounded or the one that was not rounded. So you have freedom to do what you can. So I adjusted all my values and I found the correct answer with 0 error. So you can try your own method, but this was the best. So there we have it. That is the correct thing. And yeah, you can do more research on that, but that was the best in order for me to avoid the errors. Let's move on to the next question. Question 7C. A little bit simple. So that was a question of 3 marks. We were told to from the given bearing determine the back bearing, and the simplest thing you have to know, so the difference in the back bearing and the forward bearing is that the two have a difference of 180 degrees. So the back bearing and the fore bearing, they have a difference of 180 degrees. So my answer, if I add 180 degrees and it gives me a value less than 360, that will be correct. And if my value is a little bit more than 180 degrees, I will subtract it. So on the first solution I've added, on the second I've added, but on the third, there we have 348 degrees. That was more than 180, so you subtract in order to get the back bearings. So that was that simple. Now let's go ahead to the final question. Question 8. A. Distinguish between the following terms as used in compass traversing: open traverse and close traverse, and face left reading and face right reading. A total of 6 marks. So open traverse, traverse where the first station does not coincide with the last station, it is called an open traverse. So it has no geometric shapes. You can observe the illustration there. Then a close traverse, this is where the last station coincides with the starting station, forming a closed loop. Yeah, so it goes and it comes back. Face left reading. This is the reading taken when the vertical circle is on the left of the observer. Yeah, you can see there we have a little note there. So when the theodolite is leveled, it is assumed that automatically the vertical circle index normally sets on the vertical circle to read 0, in such that the 90 degrees is the horizontal on the left and 270 degrees on the horizontal on the face right. So that is something about the vertical angles. Then the face right reading. So the reading taken when the vertical circle is on the right of the observer. So it can either be the horizontal or the vertical readings, either the two. So that was just simple as that. And then question 8b. With the aid of a sketch, explain how obstruction to sight when setting out a curve from one tangent point using a single theodolite is overcome. Total of 14 marks. So sighting, when the curve, so using a single theodolite is overcome, I went ahead, research a little bit, and so this was the best way on which that can be done. So when a fully curve cannot be set from one point, the tangent points T1 and T2 are marked in the usual way. Then the theodolite is set up at T1 and the points on the curve are set as usual up to the point P. There you can see on the diagram. Then let the total deflection angle be, that is total deflection angle be a total of that P. The theodolite is shifted and set up at P, where our readings, where we did our setting up to. Then vernier A is set at 0 and the ranging rod at T is bisected. When the angle, the total angle there, the deflection angle for the P is set on the vernier A and a point T1 is marked again. The line T1, so that is the second marking. Alpha P is the tangent to the curve of P. So there we are again forming another tangent. Then the vernier A is again set at 0, and the ranging rod at T1 is bisected. So the telescope is now transited. Then the deflection angle, so that is the total deflection angle there for the point N is set and marked on the ground. Then the process is repeated until all the points are located. The calculation for the deflection angle at the mode of setting are the same as in the Rankel's method. So that was the research I did there, and we have finished all our revision on the question paper. Yeah, that is all. Thank you for staying with me up to our last section. Yeah.